Hello everyone, it's a pleasure meeting you all in my mathematics class again. Today my topic of discussion is negative binomial distribution. We define the negative binomial distribution as the number of trials required to achieve a specified number of successes. That is, we conduct a certain number of trials in order to achieve a specified number of successes, conducting experiment which are unbiased, in the sense that it is an unbiased experiment without any favoritism, and that the trials in the experiment are independent and the outcomes of the experiment are only two, and they are either success or failure. If we take the success to be P is the probability of success, P is probability of success, then Q is equal to probability of failure. And the probability mass function of a negative binomial distribution is given by P of x is equal to R, where this R refers to a specified number of successes, which is equal to, this is x plus r minus 1, r minus 1. The meaning of this is x plus r minus 1, c r minus 1. This is the meaning of this. Into p to the power of r into q to the power of x, where x takes the value 0, 1, 2, 3, which are nothing but the failures before achieving the r successes. That means this x is equal to 0, 1, 2, 3 or nothing but the failures that come before achieving the specified r number of successes. So this is the probability mass function. So we see that a random variable x follows a negative binomial distribution if its probability mass function is given as p of x is equal to r is equal to x plus r minus 1 c r minus 1 p to the power of r into q to the power of x, where x is equal to 0, 1, 2, 3. They are nothing but the failures that come before achieving the specified number of r successes. And here this p refers to the success and q refers to the failure, and q is nothing but 1 minus p, or p plus q is equal to 1. Okay, and the expectation of negative binomial distribution is E of x is equal to r cube by p, and variance of x is equal to r cube by p square, where this x is nothing but the random variable that follows the negative binomial distribution. Here I want to make a mention that this is nothing but the negative binomial distribution is nothing but a combination of binomial distribution and geometric distribution. In geometric distribution, we try to find out the first success in a series of trials. Here again the same, and you must know that here, particularly here, if you observe, we will get this. If you get the rth success, then it means that r minus 1 successes have preceded. That is, we have already obtained r minus 1 successes, and that r minus 1 successes have got because of the combination of x plus r minus 1 r minus, that means x elements plus r minus 1 successes, and it is a combination of r minus, and the r minus 1 successes have come because of the various combinations that are taking place in x plus r minus 1 elements. So that is trials, x plus r minus 1 trials in which r minus 1 successes come in various combinations. So this is the idea behind the negative binomial distribution. Now I will the application of it is nothing but trying to find out the number of non-defective elements that may come beyond production of a certain number of productions, in which we may be interested in the probability of a specified number of successes coming. So we apply these ideas. Now here I will explain how this E of x is r cube by p and the variance are obtained. I will explain how we get this using the moment generating functions. And let me define now what is called a moment generating function. See, I write here. See, a moment generating function is mx of t is equal to e into e to the power of dx. Where x is a random variable and t is a parameter. T is the parameter. And here, so this is equal to, I'll write it as I'll put it here like this. So, the moment generating function is generally given by mx of t is equal to e of expectation of e to the power of tx, where x is a random variable. And this random variable now follows the negative binomial distribution. And so this is given by x is equal to 0 to infinity of e to the power of tx into p of x is equal to r. That means where r refers to number of successes, and where p of x is equal to r is the probability mass function of the negative binomial distribution. Now, I'll start like this. See, that is now mx of t is equal to, see, this is 0 to infinity e to the power of dx. Here x is equal to 0 to infinity e to the power of dx. This is x plus r minus 1 of p to the power of r q to the power of x. So I am writing the probability mass function. The probability mass function is here. See, PMF is p of x is equal to r is equal to, this is x plus r minus 1 p to the power of r q to the power of x. So this is the probability mass function of a negative binomial distribution, where p is the probability of success, p probability of success is equal to p probability of failure q is equal to 1 minus p, or p plus q is equal to 1. So I will rewrite here in this place. So what is that you will get here now? So this p to the power of r has nothing to do with this summation. So what I will do is, I will take that outside. I am inside the bracket, I am inside the summation. I write it as x is equal to 0 to infinity of x plus r minus 1 into p q e to the power of t of x. I'll combine this and p to the power of r can be taken outside, so you are getting this. So you see that when you start expanding this, put x is equal to 0, what is that you will get here? When you put x is equal to 0, r minus 1 into 1, because you put x is equal to 0, anything raised to power 0 is 1, and x is equal to 0, then plus you get this as, put n is equal to 1, so r minus 1 into q e to the power of 1 plus r plus 1 divided by r minus 1, r plus 1, r minus 1 q here whole square plus dot dot dot, it goes on like this. If you, that this is nothing but your NCM, just like your NCM. R minus 1, C R minus 1. The meaning of this is nothing but no, it is R minus 1 C R minus 1. That is equal NCM is equal to 1. So you see that this will become as P to the power of R. It is 1 plus, this is nothing but R minus 1 is nothing but R C R minus 1 R factorial, then R minus R, this is 1 factorial into R minus 1 factorial. So you will get this to be, this is nothing but R minus 1 factorial into R divided by R minus 1. These two will go off, giving you simply R Q E to whole to the power of n divided by 1. See, factorial 1. Then coming to this plus, if we simplify this, what that you will get here is, if you go for simplification of this, if you go for the simplification, what that you will get here is, it is R plus 1 factorial, then R plus 1, this is 2 factorial, then again it is R minus 1 factorial. So this is nothing but, this is R minus 1 factorial into n into R plus 1 divided by, it is 2 factorial into R minus 1 factorial. So these two will go off, giving you R into R plus 1. So this is R into R plus 1 divided by factorial 2 into Q e to whole square. So the next one you can very well say, you yourself can say the next one, this is nothing but what? Plus R into R plus 1 into R plus 2 divided by factorial 3 into Q into e to the power of this. This is 1, this is 2, and this is 3. This is what you will get. So this is nothing but, if you closely observe, this is nothing but your, see, this is P to the power of R into 1 minus Q e t to the power of minus R. It is minus R. See, so this, you must be familiar with this particular series. So this is nothing but, it is just like your, what I say is that if you have come across, you will know that this is what you will get. See, it is 1 minus x to the power of minus 1, 1 plus x square plus this, 1 minus x to the power of minus 2 is 1 plus 2x plus 3x square plus like that this goes on. So you see that this is 4x cubed. So if you, in the place of 1, this in power, if you take this minus r, and if you go for the expansion, this is what you will get. So in the place of this, I can write this as 1 minus q into e to the power of t into the power of minus r. So this is the value of the moment generating function mx of t is equal to so much. Now let us find out what is the mean of x. So mean of x is nothing but what? See, mean of x, that is equal to e of x is equal to mu, which is nothing but, see, it is nothing but m dash of x at t is equal to 0. So this is your first moment, that is m dash of x of t when you take t is equal to 0. That gives you your first mean. So what is that? Now differentiate this. Let us differentiate this. We have m x of t is equal to p to the power of r 1 minus q e to the power of minus r. Now differentiate with respect to t now. So this is nothing but what? d by dt of mx of t, that is m dash x of t is equal to p to the power of r into minus r 1 minus q e to the power of t minus r minus 1 into minus q into e to the power of t. So when you differentiate, you will get this. So this is nothing but what? So this is R, this is P to the power of R Q into e to the power of T into divided by R Q E T divided by 1 minus Q e to the power of R plus 1. So this is what you get. Now mean of x, where x follows the negative binomial distribution, that is equal to, this is nothing but, see, m x dash of t when t is equal to 0. So wherever t comes, we put it as 0. So e to the power of t, e to the power of 0 is 1. So this is p to the power of r q divided by, you put this as e to the power of t, t is equal to 0 means 1. So 1 minus q r to the power of 1, that is p to the power of r into r q divided by, this is p to the power of r plus 1, because since 1 minus q is equal to p. Now you see that this is p to the power of r plus 1, so you get this r into r q by p. So this is your mean. So what is the value of this one? So your e of x equal to r q by p square. R q by p square. So this is how we do. So we calculate we find out the expectation of the random variable that follows a negative binomial distribution using moment generating function. Even otherwise also we can straight away do. But I am teaching because I have already taught how to find the mean and variance using the ordinary method, the normal method. But today I am teaching you how to use the moment generating function in order to get the values of the mean and variance of a distribution. Okay. Now let us find out what is the variance of x. Now let us. So this is r cube by p is nothing but your p square. R cube by p. R cube by p is the mean of the random variable x that follows the negative binomial distribution. Now I will go for finding to find out variance. See? To find sigma of x square, which is equal to e of x square minus e of x whole square. This is what I am going to get. Now, what is this? See, we know the value of this e of x square, we know. See, this value we know. So let us try to find out. We call this as your 1. Now, e of x square. See, this is nothing but your second moment. This is your second moment. And this is nothing but your m double dash of x of t at t is equal to 0. So, this is second, e of x squared is the second moment, which is nothing but taking the derivative. Here I have taken the first derivative, then you go for the second derivative and then find the apply t is equal to 0. Now what is our this one? I will rewrite this. See, mx of t is equal to, it is p to the power of r 1 minus q r, and this is minus r m dash of x of t is equal to p to the power of r into minus r 1 minus q t minus r minus 1 into minus q e t. So this is equal to, this makes a plus, so it is r p to the power of r q into e to the power of t, r q p to the power of, they are independent of t. So I am writing it as r p to the power of r q into e to the power of t into 1 minus q e to the power of t minus r minus 1. So this is what we have. Now what is your m dash x of t? What is your m dash x of t? See m double dash. Differentiate again with respect to t. So keep this as a, this is a constant, don't bother about this. This one, no. This is e to the power of t is itself. So e to the power of t, 1 minus q e to the power of t minus r minus 1. Then plus e to the power of t, if you differentiate this, minus r minus 1 minus q e to the power of t minus r minus 2 into minus q into e to the power of t. Okay, this is what we have. Now let us not simplify this because there is no use simplifying this. So what is the second moment? The second moment is equal to m double dash of, say this is your e of x square. So this is t when t is equal to 0. So if you apply this t is equal to 0, this is 1 and so you get this r p r q. This is 1 and this is also 1, so you get this to be p to the power of minus r minus 1. Because e to the power of 0 is 1, 1 minus q is p, so you get this to be so much. Plus, so minus into minus will make it as plus. This is r plus 1, see, this is r plus 1 of q, r plus 1 of q, see, r plus 1 of q. And if you apply the, if you take t is equal to 0, well, this is 1 and this is 1. And inside this you will get it as what? 1 minus, this is also p, so this is p to the power of minus r minus 2. Because you take t is equal to 0, so 1 minus p is p, because p plus q is equal to 1. Now you take this inside, so what is that you will get here? R. This is p to the power of r means it is p to the power of minus 1 and q plus r plus 1, see, r plus 1 into q square into p to the power of r, see, r into r plus 1. This is r into r plus 1 into q square, p to the power of 1, this goes off, so p to the power of minus 2. This is what you get. So, what is that you get here? R q by p plus r into r plus 1 q square by p square. So, this is what you get. Now, I will write it here. So, this is equal to, so 1 becomes sigma of x squared is equal to e of x squared is r cube by p, and this is r into r plus 1 divided by p square into q square minus this, you square it, r square q square by p square. So you see that this is r square p square, this one goes off. These two will get cancelled. So what is that you are left with? R cube by p plus, see, this r square q square by p square, these two will go off, giving you r q square. You get this to be r q square by p square. So this is nothing but your p r q divided by p square plus r q square divided by p square. So what is that you get here now? So this is nothing but 1 by p squared into r can be taken outside, then q can be taken outside. Here R can be taken outside, Q can be taken outside, and you will be left with P plus Q is equal to 1. RQ by P square into 1. Since P plus Q is equal to 1, this implies so this is what we get. So we are able to get the value of this, that is variance of x is nothing but RQ by P square. That's all. So this is how we calculate we find out the variance, mean and variance of a negative binomial distribution using what is called your moment generating function. Now doing the problem is simple only because straightforward application you get the answer. Now let us take up the problem now. Now what is the problem here? I will read the problem now and explain how it should be understood. See, a mother feeds her child, which is a challenging task. That means feeding a child is really a very difficult job, and since the child throws tantrums, always it is very difficult because either the child will cry or do all sort of trouble, or it will throw tantrums that it will be very difficult to feed the child, and therefore it is and if the probability of successful feeding of 1 teaspoonful is 40%. That means there is only 40% chance that one spoonful of food can be fed to the child because of the tantrums it throws while eating. And now the question is, what is the probability that the mother will need exactly 15 attempts to feed the child with 10 spoonfuls? That means she has to make a 15 spoonful of attempts in order to make the child take out of that 10 spoonfuls. What is the probability? That means what? If the mother tries her best to give 15 teaspoonfuls of food or food, how much she will be, what is the probability of her success to feed at least 10, then not at least 10 spoonfuls of food? The question is, the mother is trying to feed as much as possible, but the question is, if she is having 15 spoonful of food, what is the probability of feeding the child with 10 spoonful of food? This is the question. Okay. Now, here what are the things that are given here? Here they are specified. Here the successful, it is the feeding of the child with 10 spoonful. That means all is equal to 10. That means the success here, the success of feeding. See, the probability of success of feeding 1 spoonful is equal to 40%, that is equal to 0.4. Okay, and therefore probability of failing to not to feed the child, very difficult to feed the child, so the probability of failure is equal to Q, which is equal to 1 minus P, which is equal to 1 minus 0.4, that is 0.6 chances that the child will be very difficult to be fed, and 0.4 chances that the child can be fed. Now, and here what is the specified number of success? N is equal to number of successes is equal to 10. Total number of feed is equal to 50. And here what are things known? And P is equal to 0.4, Q is equal to 0.6. Now to find what is the probability of x is equal to R is equal to x plus R minus 1, R minus 1, P to the power of R, Q to the power of x. So here it will be equal to what? P of x is equal to 10 is equal to, it is, see, there are 15, totally 50. So it is 10 plus, here you see that this is, it is x plus r minus 10. X plus r minus 10 will be equal to, here it is r minus 1 is your 4, that is 9 plus 5. See r minus 1, that means what? R minus 1, r is equal to 10, therefore r minus 1 is equal to 9. The total number is 14, so 5 are remaining, so it's 9 plus 5 plus 9, and this is r minus 9 is this much into P is 0.4 into r is 10 into 0.6 to the power of 6, 5. So this is equal to 14 C9 into 0.4 to the power of 10 into 0.6 to the power of 5. So this is the probability of successfully feeding their child with 10 spoonfuls. If you are going to, this is very simple, you can use the calculator 14C9. 14C9 you can write this as, see, 14 factorial divided 14 minus 9 is 5 factorial into 9 factorial into 0.4 to the power of 10 into 0.6 to the power of 5. If you go for all simplification here, what that answer that you will get here is, you will get the answer to be, it is 0.0164. That is the probability of successful feeding of the child with 10 spoonfuls is 0. That is P of x is equal to 10 is equal to 1.64%. That is, what is the answer that you will get now? So the answer is the probability of successful feeding of the child with 10 spoonfuls is equal to 1.64 chances. 1.64% chances. Okay. Now, if you are interested in, this is not given. Now, what is the E of x now? So, E of x is equal to, see, it is nothing but your, we just apply the formula, you will get this to be r cube by p. R is your 10 into 0.6 by 0.4, that is equal to 60 by 4, that is equal to 50. So this is you get, so your standard deviation is equal to, so this is what we get as standard deviation. So this is how we deal a problem in negative binomial distribution. And as I told you, negative binomial distribution is nothing but wherein we have a certain number of trials, out of which we want a specified number of successes. For that, we have got the probability mass function, and from the probability mass function, we can find out what is the expectation and the variances. So this is all about this. I will be doing more problems in the coming days. Thank you.